Howdy, 7th grade. Today we're going to learn two new vocab words, which are going to be arcs and central angles. But the more important thing here is arc. A central angle is kind of self-explanatory, and I think we'd be able to kind of guess what that means after I show it to you once or twice. So I'm actually going to start off with a central angle, is what we're going to do, and both of these things have to do with circles. So I'm going to draw myself a circle right here. If I start from the center of a circle and draw an angle, then I have a central angle. So a central angle is an angle that starts at the center of a circle. So that's fairly self-explanatory. Central angle starts at the center. I feel like that makes a bit of sense. So we're looking here at my circle with my central angle. It's beautiful. And if we notice, if I do this, let's imagine I cut my pie right here and I cut out a slice. I not only have drawn the angle, but now I have a section of my circle. And a section of a circle is called an arc. So an arc is a section of a circle. And that's my arc right there. It is the section of my circle, and there's a couple different ways that we can measure arcs. So arcs are measured in two ways. They can be measured, firstly, by their central angle. So let's look at this thing's central angle. It's the one we just drew. Let's say this is 30 degrees. If that's its central angle, then we can actually say that this arc is a 30-degree arc. And that works out pretty well. So the angle of my arc, same as the central angle, which would be 30 degrees. I can also measure an arc by its length, which is a little bit harder to do. So let's say that this circle right here has a radius. Let me draw that in red. That's not where the radius goes. There we go. Radius of 5. If it has a radius of 5, then we know that the circumference is going to be equal to 2 times pi times the radius, which is 5. So 2 times 5 is 10. In this case, it's 10 pi. So if I have a circle, this is still the same example. Circle has a circumference of 10 pi, and we're going to look real quick, and we're going to ask ourselves, well, what portion of that circumference is the length of my arc? Well, to figure that out, I know that the entire circle has a total, if I went all the way around here, it would have a total of 360 degrees. But I'm only using 30 degrees of that. So that's how much the circumference I'm using, and I'm going to multiply it by the the total of the circumference. So my arc is this fraction of the total circumference, which is 10 pi, which is going to be, in our case, 300 over 360 pi, or 5 over 6 pi. So all I did there was I took my fraction of the circle. This is our fraction of the circle that my arc covers, multiplied it by the circumference, and I found the length of my arc, which is great. So I found the length of the arc by taking the fraction of the entire circumference it was, multiplying it by my circumference, and that's the length of the arc. So I want to look at now just a couple real quick problems I have to do with the central angle in case they come up. These are kind of like some other things we've seen before, but I want to make sure we are well prepared for them. So we're going to say this angle right here is 30 degrees. And what if I want to find the angles A, B, and C? So I know that opposite angles, if we go across an X like this, opposites, we've already learned this, are equal. So the 30-degree angle would have to be the same as my angle B, so that means B equals 30 degrees. which is pretty nice. I also see that I have a straight line. Let me pick a different color for this. A straight line going right here. And a straight line, an angle there should be 180 degrees. So I know that angle A plus my 30 degrees has to equal 180 degrees. So I can subtract 30 from both sides, and I get that A equals 150 degrees, just like that. So I have A and B, and now I need C, but C is opposite to A, so they go across the X here, and because they're opposite each other, I know they're the same, so I could say that my angle C equals 150 degrees as well. So looking at this, because we know opposites are equal, that gives us angle B from 30. That's the easy one. And because these two angles are adjacent next to each other, I can say that they have to add up to 180 degrees. So I wrote that down as A plus 30 is 180, solved for A, found that, and I could use that relationship to say that opposite angles are equal, with which I found C. That's pretty much what we're doing today. A couple new vocab words, what an arc is, which is a part of the outside of a circle, right here, and what a central angle is, which is an angle that comes out from the center of a circle. So I hope that y'all enjoyed that, and I will see y'all in class. Have a great day.